In episode 89 of Mobycast, we introduced using private subnets for your cloud network. We learned about the differences between public and private subnets, as well as some of the key technologies they depend upon, such as NAT, or Network Address Translation. We also learned that using private subnets comes with a new problem: how to access these private resources. We discussed 3 primary approaches before settling on VPN as our choice. In this episode of Mobycast, Jon and Chris continue their 3-part series on using private subnets with your cloud network. We finish our network design by guiding you step by step in setting up a software-based VPN and building out private subnets. We also share some inside tips that will make you look like a cloud networking pro. Welcome to Mobycast, a show about the techniques and technologies used by the best cloud-native software teams. Each week, your hosts Jon Christensen and Chris Hickman pick a software concept and dive deep to figure it out.
Welcome, Chris. It's another episode of Mobycast.
Hey, Jon. It's good to be back.
Yeah, good to have you back. Today, we'll jump right into it because we're doing part 2 of a series. So this series is the VPC Ninja series. And in part 2, we're going to continue on talking about connecting to your private subnets via a VPN. Before we get started, Chris, do you want to just recap a little bit what we talked about in part 1?
Sure, you bet. So in part 1, kind of went through just Subnet 101, and when you're setting up your VPC and this concept of public subnets versus private subnets, and in particular, private subnets and what they are and why we care about them. So things that are in your public subnets are resources that are available to the open internet. And so we only really want to put resources on our public subnets that really need that direct internet access. Everything else should go on private subnets, which are not reachable by the open internet.
Right. And to just jump out even a level from there, it's like, the whole point here is, a lot of times we'll look at tutorials or we'll be learning AWS stuff, and we know in the back of our minds that there are some best practices that we should be using for security and just general setup or just what everybody does when they know what they're doing. And this is part of it. Putting things on private subnets, everything on private subnets is part of being a good cloud native developer.
Absolutely. Yeah. And we talked a little bit about just how internet access works for resources on private subnets, and in particular NAT, or Network Address Translation. So we went really deep into NAT, kind of really understanding what it is and how it works. That was interesting. So, NAT is something that everyone hears the term. They know that I need a NAT instance or NAT gateway, and NAT's going on. But do you really understand what NAT is? If you can't really explain it, go back and listen to that previous episode. So you're going to learn some things, I think, and you're going to find it interesting. I know I did. And then we also talked a bit about IP addressing and physical versus logical addressing. Basically MAC addresses which are tied to the hardware versus IP addresses which are logical, which are not necessarily tied to the hardware. And this gives rise to how can a single host have more than one IP address? Right. And so we talked a bit about that. And then we said, okay, now we've kind of said, hey, this is best practice. This is a good thing to have these private subnets and put our resources on them. Well, this opens up some new challenges of how do we access these things? Because it's no longer just a simple SSH into it from your laptop at home, right? Because they're not publicly accessible. So how do you get to those? And so we talked about 3 different ways of doing that. Basically broke it down into physical, and the physical method, the leapfrog method, and the virtual method, right? So physical was that I need a direct pipe between where I am and my cloud
Good
network.
If you're a data center.
Yes.
Are you a data center? I'm not a data center.
I'm not a data center. Also good if you've got lots of money, because it is an expensive option. We talked about the leapfrog option, which is kind of bastion host or jump host. And that's where you basically have one machine that has the internet access that you first connect to. And then from there, you can now jump to the private resources. Talked about the pros and cons with that. And then finally, the virtual option, which is essentially VPNs, virtual private networks. And that is the best of all worlds, right? It's very convenient. It's very flexible. It's got lots of different options there, ranging from very expensive to essentially free. And you have hardware options that require hardware, and then ones that don't require any hardware at all. So this week we're gonna talk about, okay, now that we've said we want private subnets, we've talked through the various options of how do you connect to those things, and we decided, like, let's go ahead and focus on, we're going to go with that virtual option, that VPN. So let's go ahead and finish our network by setting up a VPN and building out private subnets inside our VPC, so that we now have this really robust VPC network design in the cloud that is built on best practices. That's going to give us the best mix of security as well as able to do things out on the public internet.
So this is like a how-to. How are we going to do this, Chris? This is a podcast. Are you going to crack open your machine and like show us?
Well, we're going to use this brand new technology where we're streaming video to your ears and pictures to your ears. Now, I mean, this is, we're going to walk through the steps. I think it'll be pretty graspable. Is that a word?
Yes, it is today.
It is.
Language is in flux always. And today it just took on a new word.
Absolutely. So I think it's going to be something that it will be pretty easy to follow through on. I mean, obviously we're not going to go into all the specific details, but the broad steps will be there. And I think after listening to that, like, anyone would have like the recipe, if you will, to go do this on their own. So I think it's definitely worthwhile to walk through that.
Great. So yeah, should we get started?
Yeah, I mean, and before we do get started, I just want to throw a caveat out there. So one, like, so I'm not saying like this is the only way to do it or even the best way to do it, right? Because there are actually other potentially better ways to access your resources on private subnets. So we mentioned in the last episode, one of the new VPN options that AWS offers is AWS Client VPN. And so that is definitely something to look at. It's newish. It was announced back in December 2018. It is software only for remote access users. So kind of really right up our alley of kind of like the solution that we're going for that we'll talk about today. But this is something that AWS provides, and it's managed. There are some limitations with it. But that we're going to save that for a future episode. We're not going to talk about that today. So we're gonna just keep that in mind that that's out there, but we know about it. But we're not gonna talk about that.
Okay.
And then the other option that is also potentially a really great option for this kind of scenario is AWS Systems Manager, Session Manager. And so this is a tool, technology that AWS provides through Systems Manager. Systems Manager installs agent software on all the machines that you want to manage, and that agent then gives rise to the ability to connect to it.
Okay.
And so you don't need to have a VPN to do this, and you don't have to have an SSH server installed. So it's one of those things that gives you a lot of what you need without having to have a VPN or without having a direct connection into your VPC. Again, there's some limitations there, and there's some things you can do, some things you can't. That is, again, we're going to talk about this in a future episode of Mobycast. It's such a kind of a big subject, and
I could ask a single question and blow up this entire episode.
Yeah, you can. So don't. We're not even gonna. You don't even get that option, right? So I just wanted to throw out those caveats there that we do know about that, and definitely can be very viable. But we're gonna save those discussions for future episodes. Otherwise, we would never get through anything today. We would,
right.
As John said, we would blow it up. And then the other thing just wanted to point out is a great choice for doing this, again, remain like this third-party software-only VPN solution, which we kind of teased at the end of the last episode. It gives you a lot of flexibility, a lot of power. It's a great choice. So what we're going to talk about today is still a very valid, good choice for you to know about and for you to consider.
Let's throw out another benefit of it. It works in AWS and it works in not AWS, right?
Absolutely.
Yeah.
Yes. So there's nothing AWS specific about this choice.
Cool.
Yeah. So you can use this in Azure. You can use it in Google. You can use it connecting to on-prems together if you wanted to, right? Mm-hmm. So Yeah.
We also did leave out another way of connecting to a private subnet, which is to make a phone call to somebody in the data center and then tell them to tell you what they see on the screen.
Yeah.
Have I ever done that? Yes, I have done that.
Yeah, that won't work with AWS. So, because there are very few people allowed inside those data centers.
Right.
I do remember back in the day when I was at Microsoft with our data centers, and it was like it was much more accessible, and it was locked down, and you had to go through several layers of security. But I spent a lot of time inside those data centers as just deploying services and debugging because we didn't have the tools actually to do the remote access. And this was really the only way. And so we would joke that the operators there would have to put on roller skates to replace failed drives, right? Because it's such a big data center, all these rows and racks and racks and racks of servers. And, drives, you have hundreds of thousands of machines, right? And therefore hundreds of thousands of drives, like they're going to be failing constantly. So put roller skates on the operators so that they can get to those racks quickly.
Yes.
Swap out the drives. Yes.
Totally.
But different story now. And then a reminder on this, so this third-party software VPN solution that we're going to be going with today, so the rationale for choosing that is like it is very cost effective. Doesn't cost a lot of money. It's going to work for remote access users. So, you don't need to have an on-premise location, install a switch or a router or whatnot. And then it's pretty sophisticated. That's easy to manage. So really for broad strokes, it's a good solution for a lot of people that don't have dedicated network engineers, that don't have a huge budget. Mm-hmm. So we're going to go with that.
Cool. All right, let's jump right in.
Yeah. And then maybe just a personal story too. Like we were actually, John, you and I were talking about this a little bit earlier, right?
Yeah.
I have my own personal AWS account, and that's where I host my world famous personal blog that we've talked about with, I think, 3-page views in the past month. But that's another story. But so I have my own.
Shows you're keeping track though. That's good.
Google Analytics. So I have my own personal AWS account, and I'm running things like ECS and these my personal blog is hosted as a Node.js application, and using load balancers, and it's using TLS and all that kind of good stuff, right? That we would expect for best practices. But the one thing that it hasn't had is it hasn't had private subnets. Everything has actually just been public subnets, and this is true for I created this probably about 4 years ago, and up until recently, it has been all public subnet, even though I know best practices hey, my database server should be on a private subnet, right? And my ECS host should be on private subnets.
I think it's really common when you're getting started on something that you just don't want to fiddle with that, right? It's just easier to kind of throw open all the privileges. Root, you're using root, you're having wide open security groups, you're using public subnets, all the things that they tell you not to do actually make life a lot easier when you're getting started on something.
No, absolutely, right? So
but I guess to add to that, it's still not a good idea because you kind of never do get around to fixing all those in a lot of cases. So maybe it's better to just make it easier on yourself to do the right thing, so that when you get started on something, it's not like a 7-day journey of just following a few best practices that should have been fairly easy if you had taken the time to learn them and get them into muscle memory. So that's what this is about.
Yeah, absolutely. Yeah. And for me personally, it was just this nuance that comes up of, okay, once you do have private subnets, how do you connect to those things? That was for me the thing that prevented me from creating private subnets, right? Because for me, there's two big issues. One was just the time involved with going and figuring out, okay, what solution do I want to use? And then once I've figured that out, then going and get it installed and configured. So there was just some amount of effort to do that. And then the second thing that was actually a pretty big consideration too was cost. This is my personal AWS account. It's coming out of the personal credit card. And it's really just for my own learning and playing around with things and then hosting my own personal blog. How much money can I justify to spend on that per month? And so for me to go to private subnets, that means things like I'm going to have to go now pay for a NAT Gateway. I'm going to have to pay for a VPN in some form or another, whether it be hosting out an EC2 or pay license fees or whatnot. So it's going to dramatically jump the cost. And,
which should really be darn close to free, right? Like if you're doing hobbyist development and you're paying monthly fees, it feels a little bit wrong, because all the big companies, in order to attract developers, need to make sure that they're, not forcing developers that are hobbyists to pay a lot of money out of pocket.
Yeah. And I mean, there is a lot available on the free tier at AWS, but unfortunately, NAT Gateway is not one of them. And so now I'm looking at, instead of spending about $30 a month to have ECS fronted by ELB and TLS. Kind of a pretty nice, robust solution, but all on public subnets. To go to private subnets ended up probably changed that bill to go from $30 a month to about actually it's about $50 more, so probably to about $80 a month now. So pretty significant, right?
Yeah, that is. So you're already paying for cable and Netflix and HBO Plus, and not yet Disney Plus, but that's going to come around next year. Yeah. So for the personal hobbyist, for the individual developer, like, this is a real concern, a real issue. If you're a business, right, like, this is not a concern at all. So, so we're talking to folks out there that are doing this for work, for sure, probably. If you are doing this for a hobby, like, go ahead and do all these steps, create it all up, but then just tear it down, right? So you know how to do it. You've got it working. That way, it's only going to cost you a few bucks, and you get to go through this great process of just knowing exactly how to do it. All right, so I think we've teased the start of this like 3 times now. I think now we can finally shall we get started?
There, right? Yeah. So we've decided we want a VPN solution. We're going to go with a software only VPN solution, and so we're going to go look at, like, what are the third-party options out there. And so there are tons of options out there in this space, ranging from paid commercial products to free open source products. You can go to the AWS Marketplace and do a search for VPN, and you will see just a bunch of options there for manufacturers like Checkpoint, Microsoft, Cisco, just lots of options. But again, you're going to pay for it as well. There's open source options out there like Soft Ether, OpenSwan, and there is the community version of Open VPN. There's probably even other ones out there.
I'm sure you could run through your spam folder and find 4 or 5 different options.
Probably. Indeed. And along with, like, don't choose those options. Give us remote access to your machine. We'll set it up for you because your Windows server needs to be updated. And
right. So exactly, that's what I was getting at.
Yeah. Please don't do that. So we want to keep costs down and still have an easy to use, well supported version. Like I said, it looked at Soft Ether. It is. It's a viable option out there, but it is very much one of those things where it's going to require a lot of work. It's not particularly well supported. In the past, someone put together a AMI and put it on the marketplace that you could go and use, and that's no longer even there. It's just kind of like suffered technical debt and rot. So it's you really have to go build your own now. Again, possible, but a lot of work. Kind of same deal with OpenSwan. Open VPN, though, there's a company behind it. It is open source, and you have the community version, which you can go and doesn't cost a dime, and you can go configure all that and set it up and run it yourself. But then they also have like the paid versions, and those are very well supported. They have all the software around them that does the administration and the setup, right? Just making it so much easier. So OpenVPN, very well supported. Lots of folks use it. It is one of the ones that AWS would recommend, I think, as for a VPN service in AWS. And it comes in 2 flavors. So one is hosted, where you just pay by the hour through Amazon, through AWS. When you do that, it kind of works out to call it about $2 a day or $60 a month to do that way. But that includes the EC2 as well behind it. And then they also have they have a BYOL version, right, which is bring your own license. And so this one, you only pay for the EC2 resources that you use. And so like, for me, in my particular case, I can host this on a T3 micro, and that ends up being about $7.50 a month. And then I just have to take care of the licenses. And so you can buy licenses from Open VPN at $15 per user per year with a minimum of 10 users, right? So it's $150 one-time fee. Now you have 10 users, up to 10 users that could use it, and you're good for a year. So you're looking at $750 a month plus $150 a year.
That seems fairly startup friendly, that pricing.
Yeah. I mean, and it gives you, 10 users. I mean, that's, again,
it's your whole dev team for a year.
Yeah, absolutely. But the kind of like the little loophole or really nice thing here is that if you choose the BYOL version of it, you don't actually have to give it a license key to use it. So all functions are available without any time limit. The only limitation is that you can only have 2 simultaneous VPN connections to it. So for me,
that's great.
This is perfect, right?
Yeah, hobbyist level.
Yeah. So this is what I did. So I went to the AWS Marketplace and searched for Open VPN Access Server. I chose the BYOL version, and then I'm good to go. So now the only thing I have to pay for this VPN really is just the $750 a month for hosting the T3 micro on AWS.
That is not an expensive VPN. That's great.
Yeah. So that's what we're going to do, right? So let's go and install Open VPN Access Server. And what are the steps that we need to do? And so, like I said, what we're going to, the very first step is we're going to go launch a new EC2. So we're going to go into the AWS console, go to the EC2 dashboard, and launch a new EC2. And when we do that, we're going to go to the marketplace, right? So the marketplace will be an option there for it. We'll click on that, and then we will be able to now search. And so you just type in Open VPN Access Server. You'll see those pre-built AMIs. Choose the BYOL version.
Okay. And so you're specifically looking for an AMI that's provided by OpenVPN.
Yes.
Yeah.
Yes. So now you're just going to go through the normal process, right? Of whenever you spin up a new EC2, right? It's just, this is the way the AMI, instead of choosing like Amazon Linux 2 or something like that, you're actually just choosing this AMI through the marketplace that's already pre-built for you. And so you go through and you'll tell it, like what VPC you want it on, what kind of instance type you want. The one thing that you need to make sure that you do when you install this is just make sure that you're selecting a public subnet for the instance, right? So like your VPN server has to be on a public subnet, not a private one. Otherwise, you're not going to be able to connect to it.
Sure, makes sense.
Yeah. So once we've now spun that up, another thing we're going to want to do is going to assign an elastic IP to it. And so that's so that we can have this dedicated IP address that is well known that we'll be able to use to connect to it.
Cool.
Another step that I did is I went and I created a Route 53A record for this EC2, and so I can give it a friendly name so I can remember it. So if for me it's vpn.chrisic.com. So that is now assigned to that with that elastic IP. So now I can just always, whenever I need to connect my VPN, vpn.chrisic.com.
So if you want to try to break into his VPN, it's vpn.chrisic.com.
Yes, indeed. I have it pretty well locked down, so I welcome the challenge.
Yeah, DDoS only is what's going to work on that. Because you can only have 2 active connections at once, so should be pretty easy, everybody.
Well, you have to successfully connect to it, right? So,
but can't you, doesn't it count as your failing try? Who's going to know the password?
It's password 123. So, yeah. So now we've spun this up. We've got the IP address, and now we've got the DNS record for it as well. And then there's just some general setup, installation, admin stuff to do, right? So it's like you're going to SSH that instance. There's an install wizard. You just run that when you SSH into it. You can then go and definitely change the default password, right? That's like, this is true. Like when
probably
you install
should do
route,
it on your VPN server. Yes.
Yeah. So admin, not so good. So change that, update the OS, those kind of things. And then at that point, you can then log in to the web-based UI. Now you can have this really nice way of configuring your Open VPN server. So one of the things to point out here is that, how do you manage users? So Open VPN gives you a range of options. So, if you have LDAP, it can use that. If you have a radius, you can use that. But it supports this really, really straightforward, easy thing called local authentication. And so what that is it's just it has basically a user database that's local to the machine.
Okay.
Right? So you don't need any integration. It's really easy to do. So you can just configure users right there, and just here's their username and password, right? And just set them up. So it makes it just really easy. This is one of the things that AWS Client VPN does not have you can't do with it. With client VPN, setting up users is much more challenging.
Mm-hmm. I imagine you have to pull in other AWS services, which is kind of typical of AWS. Like you might have to connect it to IAM or Cognito or something like that.
It actually uses certificates.
Okay.
But
AWS Certificate Manager. There you go.
Kind of. You actually have to create the certificates yourself using open source tools that you then import into Certificate Manager.
Remember when I said about blowing up the episode?
There it goes. No, we're going to keep moving on.
Okay.
Another great feature that OpenVPN has is that it supports MFA through Google Authenticator. So
cool.
You can lock it down even more that way. And then the last thing you need to do is you want to set up TLS for VPN, right? So you want to be able to access it securely encrypted, encryption over the wire. It does come with a self-signed certificate, right? But that's not going to work for if I want vpn.chrisic.com, it's not going to work with that, right? So This was one of the challenges. Is okay, how do I want to do this? Mm-hmm. And so I thought there's two possible ways I thought, right?
I'm imagining you were thinking about putting it behind a load balancer.
Yeah, absolutely. So that was my first. It was boy, it would be so nice to use AWS Certificate Manager. I already have a wildcard cert for my domain in AWS Certificate Manager, so wouldn't it be nice to use that? And so what if I fronted this with an ALB and then use that certificate, right? Because with the certificates that are created with Certificate Manager, you have to use those with AWS resources, and specifically, you can really use them with ELBs, CloudFront, and API Gateway. So I'm not going to use CloudFront or API Gateway for this, but ELB, yeah. So, what if I go ahead and create a target group for my EC2, that Open VPN Access Server EC2, add that to an ALB, and then have the ALB perform the TLS termination. That was my first thought, right?
Yeah.
And very quickly discovered, unfortunately, this is just not going to work. So for a bunch of different reasons. So OpenVPN itself does not work behind a load balancer. ALBs in general are really designed for HTTP and HTTPS traffic, so port 80, port 443. OpenVPN uses some other ports as well, so that makes it problematic. And then getting health checks to work and just dealing with these other port issues, right? Just kind of, for all these reasons, is okay, this is just not going to work all that great. So had to fall back to kind of the option I know was going to work all along, but I kind of didn't want to do it, which is, okay, we have to go basically create a SSL cert, right? And install it on the EC2 itself. So that's the route that I went. This is pretty...
Yeah, it sucks. It's rolling back time to 2015. There you are, cracking open SSL.
Yeah,
doing it.
I mean, the good news is in the past it used to be wow, this costs $400, right, to go get an SSL certificate, and it used to take days and days for it to be made available because they had to do various checks, right, and whatnot. That's now changed with now you can do things like email validation or domain DNS validation. And then now there's companies that do this for free as well. So Let's Encrypt is definitely one of those free ones. I ended up using Zero SSL, which is kind of like a really nice wrapper around the process for using Let's Encrypt.
Okay.
And so very quickly, I mean, literally within a matter of, 60 seconds, using zero SSL, had a Let's Encrypt SSL cert for my VPN. And then I just installed that cert using that web-based UI. And then I was off and running.
Oh, that's handy. That's nice that they did that. You didn't have to go dig around in the file system of the EC2 to figure out where to put it.
No.
And then change it, schmod to make it executable or something.
No, just prepare your cert and upload through the web-based UI and away you go. So
Sweet.
Did that.
Very
now
cool.
I have my TLS, and then the last thing for me was just to lock down the security group for the EC2 that was hosting the VPN software, right? So understand exactly like what ports, the minimal number of ports that I wanted open and where I was allowing that traffic from, right? So things like I still want to be able to SSH into this, but I made it so that SSH is only from inside the VPC. So only once you actually have a VPN connection can you SSH to that particular machine.
We cover a lot of information here on Mobycast, and if you've ever wanted to go back and remind yourself of something we talked about in a previous episode, it can be hard to search through our website and transcripts to find exactly what you're looking for. Well, now it's a lot easier. All you have to do is go to mobycast.fm/show-notes and sign up. We'll send you our weekly, super detailed outline that we use to actually record the show. A lot of times, this outline contains more information than we get to during our hour on the air. So sign up and get weekly Mobycast cheat sheets to all of our episodes delivered right to your inbox. So let me just make sure that I know where we are here. We chose Open VPN. You started an EC2 instance with Open VPN's AMI. Then you configured your, like, as part of configuring Open VPN, you set up wait a minute. Let's back up a little bit. After having the EC2 running, you got in there, and did you have to do anything like with the command line, or
so
or
you just so after it's been spun up, we assigned the EIP to it, we created the DNS name for it. We can then SSH in. You just SSH into it. You're going to be presented with, okay, hey, run this install wizard. And so you'll go through that. It'll ask you some.
Oh, it automatically does that. It's like, hey,
you'll see that the message
of
the day is configured to show you this, right?
Cool.
So
Sweet.
So you go and run that, and then once you run that install wizard, basically you're telling it what ports to actually start up the VPN service.
Okay.
At that point, you can then exit out, disconnect from that, and then that's when you now log into the web-based UI. Right. And
in the web-based UI is where you're setting up your user accounts using, in your case, the local authentication.
Exactly. Yep. And then you can change
cool.
things like the host name so that it's now, vpn.chrisic.com, and you can set up MFA and those kind of options and whatnot. And then
lastly, you set up TLS, and you did that by using not the what was the name of the TLS service or the certificate service that you used?
So use zero SSL, which is a wrapper around Let's Encrypt.
Let's Encrypt. That's right. Okay, cool. All right. So now you've got the whole thing running, and it's behind TLS. What are we going to do next?
Yeah. So now at this point, we have our VPN access to our VPC, right? So we now have a way to access private subnets. So let's go ahead and now we need to create some private subnets.
Okay.
Let's walk through that real quickly. So
there's a really subtle point you just made. It's like set up your VPN before you set up your private subnets, and then your life will be easier when you have those private subnets. You don't have to, because you have your VPN and you make sure it works, and then you can set up the private subnets, because then you can get into them. You don't have to go it's sort of like I'm imagining unit testing. Like, the other way you could have done it is to set up private subnets that you wouldn't be able to access, and then set up your VPN and keep banging on it until you can access them. Mm-hmm. That seems sort of more the unit testing approach, but the approach that you just mentioned actually seems easier. Seems like less possible things could go wrong if you get that VPN set up first, and you know that the VPN is not going to be the problem. It's set up. It lets you get into your VPC.
Yeah, and it's less risky too, right? So it's like, imagine, say, go create my private subnets first. I put my database on there, and then now I'll go set up my VPN. Well, in the meantime, you can't access your database, right? Or maybe it's your ECS cluster or something like that. And like maybe you're having problems doing that, and now all of a sudden like a crisis comes up and you actually need to access those machines. Like, well, sorry, not going to happen. You have no way to get there unless maybe you do have a friend that works at the data center you can call, right, or something like that. Okay, yeah, it's not going to happen. So anyhow, so if we create the VPN first and we know that it works, then proceeding with building out our private subnets is just takes away that risk. And again, it's another problem. It's not the VPN. If you do have problems, right?
Right.
So we talked about like private subnets are just subnets, and it's just their routing is different, right? They're not accessible from the internet, is what makes them different from public subnets. So what we're going to do is we're going to create some new subnets that will act as our private subnets. So one thing to consider with this, right, is like, okay, a subnet is tied to a specific AZ, right? You can't have a subnet that's spread over multiple AZs. And so we know that we want a multi-AZ architecture, right? So that we have more resilience to failures and have higher availability. So at the very least, you want at least subnets in 2 AZs. And, in general, like if you can go to 3 and if your region supports that, then that's even better, right? So like, again, a good example would be like if you had 2 AZs with 50% of your load in each AZ, if an AZ fails, right, then that means 100% of your load is now being brunted by the single AZ, which may be a problem.
Sure.
Versus if you have 3 AZs and a third of your load is spread across each AZ, if one fails, then it's now half the load is on each of the remaining 2 AZs.
Right.
Which is a lot more doable. So we're going to choose. So I'm running in US West 2, Oregon, and that currently has 4 AZs available. We're going to choose 3. So let's go create 3 new subnets, 1 per AZ. So we can go into the console there, go to the VPC area, go to subnets, and just create new subnet. We can pick our CIDR ranges. And so for just kind of keeping things simple, for me personally, especially since this is for my own personal site, I can use a /24 range, which gives me it's basically 256 addresses, right?
It feels perfect, right? It's like more than you'll ever need, but
it definitely for like a personal account for sure, like /24 is a good choice. So create 3 subnets. I'll put them in each one, obviously making sure each one is in a different AZ. And so I'll name them something that makes sense to me. So it would be like private-A for this private subnet that goes into the US West 2A, and private-B that goes in US West -2B, and private C for US West 2C type thing. So we now have our 3 subnets spread across 3 separate AZs. The next thing to do is we need to create a new routing table. And so this is going to be our private route table. So there in the VPC section, there'll be a route table option over on the left side. So we'll click that. We'll now say we want to create a new route table. And in this route table, subnets get a route table associated with them, right? So
let's just define what a route table is real quick. It's a thing that's going to, in your mind, as you imagine the network, you can imagine it living on the routers that sit between where all your computers are and the rest of the world, the rest of the internet, so to speak. I mean, that's maybe not exactly where they are or what they are, but for all intents and purposes, it seems like a fair enough visual to have in your mind that there's this little machine that sits between your computers and the internet that tells you that your machines can talk to figure out what they're going to do when they do stuff.
Yeah, I mean, think of it as you have a path. So
it's a router, right? And on the router is going to live this route table. That's what I'm getting at. I imagine like a physical device, but it probably isn't. But it's in charge of deciding where things are going to go, where messages or packets essentially are going to go. And the reason that I like to picture it between my subnet and the rest of the world is because it can talk to, every single one of the computers on my subnet can talk to it directly without talking to any other machine. That's kind of the main thing I'm getting at. they all have direct wired up access to this thing, whatever this is, essentially.
Yeah, maybe there's
again, I don't know what really is happening. Like, sorry to interrupt, but I don't know what really is happening on the floor in the AWS data centers. And it could be that, you know, my entire subnet is like in just 2 actual computers, and even though there's several VMs, like I don't know what's really going on. And the router could be just some software running somewhere, and it could be that there's even multiple hops to get from those machines to that router. But in my mind, like as I think about this, like the machines that are running that I'm setting up a route for, they have to be able to know where to send packets. And so they need to query a route table. Basically, hey, route table, tell me what to do with this.
So that's exactly what a route table is. Basically just a lookup table, right? That kind of says, okay. Mm-hmm. And by the way, the route table lives on every machine, right? So when you assign a route table to a subnet, basically any resource spun up in that subnet gets that route table loaded onto its machine itself. So when your EC2 host says, oh, my networking, I need to send a packet to this other particular machine, it's going to look at its route table to figure out where it should send that packet to, right? So it's the instructions for...
That's a little bit of a... Yes, you're right about that, but also you can change the route table locally. So you can actually break your routing by just going on to your route table inside Linux on a specific machine that's in that subnet, and break its connection or break its networking by just changing the route table there, or augment it, not just necessarily just break it, but augment it or change it. So what I think you're getting at is the whole protocol of the way route tables are, like, they have kind of like DNS itself. They have like a hierarchy to them. And like, I think what you're essentially saying is, like, at the router level, that gets copied down to the local level, but you can still change it locally too. Like
a router has its own route table. Mm-hmm. Just like each computer has their own route table, and they may get them from different places, right? So like, but it's just a lookup table that says, okay, I need to send a packet to this IP address. Like, the route table tells me how to do that. And if there's no range in that route table for that particular IP address, then it has no idea where to send it, so it can't, right? So it just gets dropped on the floor.
Yep.
So, but networking, actual physical networking equipment like a router, it just has its own route table, which that's going to be perhaps even different, right?
Yeah, I guess I really do want to understand this, because this has always been one of the things that's confused me about using AWS. And maybe if you can help me through this, other people will learn from this too. So I was trying to say that the route tables live somewhere else. And the reason I was trying to say that is, like, you literally don't configure it on every machine. You literally are not in each machine setting up a route table when you set up a private subnet. In fact, you might not even have any machines in your private subnet. In fact, when you create a private subnet, you don't. There's nothing in there. But you're setting up a route table. So where is that thing? And I guess my question is it living on a router and then getting copied to every machine? Or is it living somewhere in like an S3 bucket or something? And as machines get spun up, there's some software that knows to go and place that route table into each machine. Mm-hmm.
Yeah, I mean, I think, for AWS, in their case, like, this is just a service, right? So it's all software. So it's just somewhere so that when you spin up an EC2 inside of a subnet, right, that's all software, and it's part of its initialization and configuration. It says, okay, what's the route table associated with the subnet? And now configure that EC2. Its route table now has that information, right? So, and so that's its route table now. And if you make changes to that, right? If you make changes to that in the VPC console, right, then those changes get pushed to the machines that are there as well. But it's all there local to the EC2, so that when it wants to send network packets, like, it knows where to go.
So I think something that I said was incorrect. Then let's correct something I just said, which is I was like, sort of suggesting that this route table concept is hierarchical, like DNS is, and that maybe there's like a master route table and individual route tables. That's not true, is it?
No.
Not true. Okay, so that was incorrect. But the reason I got to that conclusion is because you can make a route table without any machines in your network. Mm-hmm. And so I was like, oh, well, it must be for something. Maybe it's in the router, right? See how I deduced that? Like, the route table has got to be somewhere. Maybe the router is like owning the route table and like the machines as they go on are using the router's route table. But no, that's not it either. It has its own route table. The machines have their own route table. And this route table that you make in AWS is just like, I guess it's just a file that it's storing somewhere and then applying to each machine as it loads up.
Yep.
Yeah. Okay.
And I mean,
cool.
and so the subnet's not complete without a route table, right? So like you couldn't, like, if you didn't define a route table for a VPC, even though there's no, I mean, for a subnet, even though there's no machines in it, well, once you did put a machine in it, then it's like, but it's networking, it's broken, right? So it's the subnet definition was incomplete without the route table.
It's so wildly confusing for me because so much of what you do on an AWS Linux machine is like, you got to do it. You're in there and you've got to actually set it up yourself. Like if you want to update the operating system, like go update the operating system, log in and update the operating system. But other stuff is like handled in the console sort of separately, like this route table thing. Yes, it is something that the operating system actually needs to get into itself and has to be installed in there. And you could go, like I said, you actually really can go change it.
Oh, absolutely. Like, and this is a whole nother topic. We'll talk about it in a future episode about how Docker works. But like when you're running containers, like they're manipulating route tables, right? To set up these other networks, right? So there's a private Docker network that gets created, right? And that's all done through route tables. And like, how does container networking work on a particular machine inside Docker? Like, this is all route tables,
right?
IP tables and whatnot. So
knowing the difference between the stuff in the AWS console that kind of applies to like, well, this is how the hardware is configured and that sort of like infrastructure, I guess, with a capital I, versus the stuff that's actually configuring the operating system of the machines that you fire up is tricky. And there's not like a line in the console that's like everything above here is like, you know, wires and machines and everything below here is your operating system stuff. That would be kind of nice, huh? From a user experience perspective.
Yeah, unfortunately, I don't think the line would be so clean. It would I think it would end up being like a circle, like that looked like a blob. You know, it just wouldn't be clean. There's just so much going on, and things have blurred between like things that used to be in hardware are now in software. Things that used to be in software are now in hardware. Sometimes now there's special chips being made for certain. I mean, it's always changing, right?
Yep.
Yeah. But the principles are there, right? Like that's not
right,
and that's why like. If you understand networking 101, then like setting up a VPC ends up being like, this makes sense. I understand this, right? I can use some of the same concepts and techniques. These all apply. Like how they actually get implemented might be different, but the concepts apply.
Cool.
Yeah, cool. So we have our private route table now that we've created. We're now assigned that to our private subnets. Another thing we'll want to do too is we'll just want for the VPC that we're putting these subnets in, we'll now want to make sure that this new private route table is the default, the main route table for the whole VPC. That way, when we're creating subnets, by default they're going to be private, and we have to manually change the route table to be the public route table to make them a public subnet. So it's just, again, kind of a best practice type thing to err on the side of being more conservative with the access. So after we have the route table, then we need to leverage it to actually get out to the internet. So that's where the NAT Gateway comes in. So we need to create a NAT Gateway. So we talked all about NAT in the previous episode.
Right.
AWS has a service, NAT Gateway. It's managed, it's scalable, it's up to like 45 gigabit bandwidth. This is definitely the way to go to do NAT in your VPC. So we just create a NAT Gateway. We put it into a public subnet. Very important, again. It needs to be in a public subnet. Next
to our VPN machine?
It doesn't have to be in the same subnet as our VPN server, but it does need to be in a public subnet.
Okay.
And then assign an elastic IP to it. And then once we've done that, now we can go update that private route table to say, okay, for all traffic that's not internal to the VPC, we'll add a catch-all route that forwards to the NAT Gateway. So basically this says like, hey, if this network packet is going to somewhere other than inside the VPC, aka it's going out to the internet, then here's the catch-all route for that 0.0.0.0/0, which says everything else, and that goes to the NAT Gateway. And then the NAT Gateway will then make sure that now goes out through the Internet Gateway. And now this way, machines on the private subnets can now make outbound connections to the internet. through NAT and through the Internet Gateway.
Right on. And it's backwards from that, right? Like the first statement in the route table is like, hey, everything in this route using this /24 for your kind of sitter block, like everything inside this subnet, whatever the numbers are, and then /24, basically to say this range of IP addresses stays inside. And then you say 0.0.0, everything else goes out to here.
I think that's the way it gets displayed to you. It doesn't matter what order you create it in, because at the end of the day, it's the most...
Well, wouldn't it though?
No, because
like,
with
hey,
route
so
tables, the most specific route wins. They're not applied in order like NACLs. No, they don't get applied in order like NACLs, right? It's the most specific route wins.
Secrets of the pros right here.
Well, otherwise it would be chaos, right? Like this would be like everyone. Could you imagine?
Yeah, it would be
the
right.
uproar, because like everyone would be caught out by this, and they'd be like, "Why do you make it this way?" So
cool.
Yeah. So and that's it. So the last step is just then we can just test and verify that now our VPN's working and we can access something on our private subnet. So like for me personally, I just spun up an EC2 on one of those private subnets. It didn't have a public IP. It's just the private IP. I then enabled a VPN connection, and then I did SSH from my laptop into that private IP. And first time is a charm. There you go. So we now at this point, we have it set up. We have our VPN, and then we have our private subnets, and we have machines on those private subnets that are not accessible from the open internet. You have to have the VPN connection in order to connect to them.
Wait, I missed the part where the VPN on the public subnet was configured to be able to get access into the private subnets.
Well, it gets that by default, right? So like, because it's inside the VPC. So it's using the public route table. And the public route table has a route in there that says, okay, for anything, like it can talk to anything inside the VPC.
So the entire VPC can see itself.
Mm-hmm. Yeah. You'll see this by default. Like this is what route tables will add for you when you have a route table in your VPC. In fact, I believe you can't even change it. You can't delete it. Like it's just there. So. Oh,
seriously? Because I was just about to say, I bet if you wanted to, you could actually lock off. You could create like a public subnet that was in the same VPC as a private subnet, like lock the private subnet away from the public subnet, even though they're all in the same VPC. But what you're saying is like, nope. The very first thing that happens when you make a VPC is it gets a route table where everything inside the VPC gets to see everything else. Mm-hmm. Okay, interesting. Yep. This stuff. it like doesn't stick. Like it's weird how certain code stuff sticks in my head, but networking stuff for whatever reason does not stick in my head the same way.
Yeah, well, I mean, again, it's a big open topic, right? There's lots of things to know. I mean, this is why AWS in their certification offerings, they have one just for the advanced networking specialty.
Yeah,
right?
Totally.
There's enough information there that it warrants its own certification exam.
Right. So I think, I guess a part of it is just like experience and like miles traveled. Like, before the advent of AWS, you needed to travel a lot of miles or have a very specific job type to deal with big networks, to deal with, right? You had to be sort of an operations person or a network person in order to even think about this stuff. And otherwise it was kind of set up for you. And, here's your command to get to the thing you need. Mm-hmm. And these days it's like, hey, you can set up 100,000 computer network in an afternoon.
Yeah, absolutely.
But you don't know what you're doing because you never had that job before.
Yeah. But, there's only one way to get that knowledge, and that's to, experiment and to use it and play around with it. So, yeah. I wanted to point maybe just a few pro tips that are related to this. So one is CIDR block considerations, right? So like when we're creating our VPC, when we're creating our subnets, we're going to specify CIDR ranges, right? And so those are going to say like, okay, what is the range for IP addresses being used by either the VPC in general or, the particular partitions inside the subnets. And then how big is it, right, with the mask? So we talked about like /24 represents 256 addresses. I think it's /16 is 64K addresses. And then the smallest one, I think, is /28, which is 16, if I remember correctly. So a couple things to keep in mind, right? So you want to make sure when you're kind of setting up networks, whether it be like if you want to be able to at some point have multiple VPCs. You want to have more than one subnet. Like, you want to make sure that it's non-overlapping IP ranges, right? Otherwise, you're going to run into some big problems. Mm-hmm. So you want to make sure. And we can break this down into VPC and subnet. So at the VPC level, you want to allocate a single contiguous CIDR block that's non-overlapping with any other VPCs that you may have. Mm-hmm. It's kind of tempting to make it big, right? So just do /16 or whatever like that, right? And now you like, hey, I got all the flexibility in the world. But you need to be careful of that, because if you do make it too big, you're going to run into problems potentially with overlapping IP ranges. Mm-hmm. But if it's too small, right, you're going to run out of IP addresses. So you wouldn't run into that at the VPC level. You wouldn't run into that unless you tried to do something like peering your VPCs, right? Like, if it's too big, right? If you let in like hundreds and hundreds of thousands or millions of computers in your range, the only problem that would happen is if you tried to have two VPCs and then peer them, and then all of a sudden your VPCs could potentially have computers with the same IPs because the ranges are overlapping, right? Yeah. It's just don't think it's so much as VPCs, just other networks. And so just by virtue of having a VPN connection, we actually have another network, mm-hmm. right? Yeah. So like for me, accessing the VPN from my home office on my laptop, my particular router, I'm setting up my own private network, right, with its own IP range. Mm-hmm. And so if that overlaps with the private IP range of my VPC, I'm going to have problems when I establish a VPN connection. So if your VPC is going to talk to any other networks at all via direct connect, via VPN, or via VPC peering, or any other way, then that's when you could have these collisions at the VPC level. And that's why you want to be mindful of your size, right? It's like, don't go necessarily with the biggest one that's there, because that's going to, again, maximize the chances that you're going to have this problem with overlapping CIDR blocks. So be very mindful of that. And it's like, think about like, okay, how many IP addresses do I really need here? Estimate above, go above that, but not drastically above that. So like me on my personal account, something like, 1K addresses would probably be more than enough ever. If I have more than that, then it's like, hey, something's going. It's not a personal blog anymore. Yeah, it's going really well, right? In which case, we'll just burn it down and start over. Mm-hmm. Yeah. So that's something to keep in mind. Is just your CIDR block considerations when you're creating your VPC and your subnets. And again, it's not just for your AWS networks; it's for everything else that may connect to it, whether it be VPN or on-site or whatnot. And then one other thing I wanted to just point out is that NAT gateways are single points of failure, unlike Internet Gateway. So Internet Gateway is not per subnet, it's multi-AZ. NAT gateways are single AZ. And so that means that if that particular AZ goes down that the NAT gateway is hosted in, well, you have no NAT anymore, right? Mm-hmm. So for best resilience, you really want to have multiple NAT gateways, ideally one per AZ. That way, if an AZ does go down, it's only affecting the resources in that AZ. So what you'd do is for every single one of your AZs, you'd create a NAT gateway, and then you'd have separate private route tables, one per AZ, and each one of those private route tables would then forward to its particular NAT gateway. So that way, if AZ-A goes down, then, and it was using the NAT gateway and AZ-A, the other two, B and C, are not affected whatsoever. So a typical thing that people do is they'll just create a single NAT gateway and think they're good, but they'll find out that if there's an outage in the AZ that NAT gateway is hosted in, then now all of their private subnets have lost internet connectivity across the board, right? Yeah, that's terrible. Mm-hmm. And it's also like a kind of a limitation. When you say managed service, it's like mostly. Like, well, it's managed. It's just single AZ, unfortunately. Right. So, So it's not highly available. Yeah. Cool. All right. So just a quick summary. So now we have our VPC. It's got public and private subnets. We only have our public facing resources on the public subnets. Everything else is protected on those private subnets. And we now have secure access to those private subnets via a VPN connection. So now we can start moving applications onto our private subnets. But I think that's going to be in the next future episode of Mobycast.
Sounds good. Well, this was pretty interesting. I learned a lot, like just about how this stuff fits together, stuff that I've used and clicked on and had in my own systems. Thanks for educating me and getting me over a couple of like learning hurdles that I had. Thanks so much, Chris.
Awesome. Thanks, Jon.
Yep. Talk to you next week.
See ya.
Bye.
Nobody listens to podcast outros. Why are you still here? Oh, that's right. It's the outro song. Come talk to us at mobycast.fm or on Reddit at r/Mobycast.